Hey guys, Brian here with a quick showcase video of Animagica, my animation library for Three.js and the web. Animagica is a JavaScript library that comes with an editor, which is what we're looking at right now. The editor allows you to create animation graphs, similarly to Unreal Engine's animation blueprints, for example. We can export these graphs to use them at runtime with our games or 3D applications. Right now we're looking at the most simple graph possible, which is a single animation node connected to the output. Maybe we just create a new one real quick, call it simple. Once we connect that and hit play, we see that nothing is happening. That's because we need to associate an animation clip with each node. So let's maybe look at a few. So we have some combat animations, some emotes, and then let's maybe get back to the run animation. So that's it for the moment. In the next video I want to show you guys how to blend multiple animations together in Animagica. Last time we looked at playing a single animation node. Today I want to show you guys how to blend two or more animations together. Here we have two animation nodes, run left and forward, and we feed them into a blend node that takes a numeric input that will control the blend. If we go into our work in progress blend space UI, we can preview how the parameter will control the blend. So we can see that it smoothly blends between the two. Now I want to add a third animation. Let's call it run right and connect it to the blend node. Select a animation clip, and if we now play and go into our blend space, we can see that it's updated to show all three animation nodes, and now we can blend between the three. Hey guys, this video will be about state machines. We can double click a state machine node to open it up. Inside we can create state nodes, which we can in turn open up to get a similar view to the main graph, where we have an output node that we can connect an animation to. That could be a simple animation, but it could be a blend as well, or a full state machine again. Really aren't limited in our options here. As soon as we have more than one state, we can define transitions between them. Transitions are basically crossfades, where we fade out the animation of one state while fading in the animation of the target state. When we click on the transitions node, we get a secondary view with a default transition created. Let's delete that and create a new one. Transitions have a bunch of options here, as well as the ability to create a condition. For example, let's use our speed parameter here and say if speed is greater than 0.5, we want to take this transition. Now let's define a couple of more states. Maybe we have a run state that we want to connect to. And at this point I kind of wanted to show you how state machines can easily grow in complexity if left unchecked. For example, if we search for Unity animation state machine, we get some screenshots of real-world state machines. Same goes for Unreal. We have these monster state machines where nobody knows what's going on and nobody wants to work with them. So I want to show you how easily this can happen and how to prevent this. So I've set up some extra states down here for jumping. Jumping usually consists of at least three animations: jump, start, fall and land. So let's say we can go from idle to jump, from walk to jump, and from run to jump, and then from land back to idle. And for walk and run we want to transition directly from fall, because we might want to skip the land animation in this case. So we can see that we already have a bunch of connections here, and at this point we might realize, oh wait, our character can actually go from any state into falling, because they might run off a platform, for example. So we have to define some extra transitions from idle to fall, from walk to fall, and from run to fall. And at this point we can already kind of see where this is going. This is becoming messy. So I want to show you a different setup that I have right here. We have our 3 states, idle, walk, and run. Each of them is marked as a global state. And if we click on the global transitions node up here, we get a secondary view in which I've set up a bunch of nodes. Conceptually, this is similar to Unity's any state, where we can define a transition that goes from any state to a specific global state. So here we have a kind of range check, where we check if speed is greater than 0.5, we go to run. If it's less or equal, we go to walk. And if it's less than 0.1, we go to idle. So this has already helped us deleting a bunch of edges between these states. And now our jumping state is still missing. For this we create a state group, which you can double click to open up. In here we can create a bunch of more states. So let's copy these states from before. Let's do jump start, jump fall, and jump land, and set up the transitions between them. And now if we want to go from idle to jump, we see there aren't any options for transitions here. That's because we need to define an entry state for the state group. So once we've done that, we can define a transition from idle to jump start. And similarly, if we do the reverse transition, jump to idle, we need to define an exit state. So land is our exit state, and we can now define the transition. Now in our previous setup, the transitions from jump to run and walk were defined from the land state, but we wanted to go directly from falling to run. So we define a second exit state, fall, and we selected in these cases jump fall to run and jump fall to walk. And all that is missing from our previous setup was that every state can go into the falling state. So for this we open up our global transitions again. In here we are only seeing the global states of the state machine right now, but if we go into jump, so, mark our falling state as a global state as well, and now tell the jumping state group to lift up its global states, then we get the option to transition right into the group from any state to jump fall. Condition wise, we would probably have some Boolean parameter is falling, which controls the transition. And now if we compare these two, we can see we've already cleaned this up quite a lot. This isn't going to scale really well, while in here we have a lot of control. If we don't like what we work towards, we can still refactor it into more state groups. We can nest state groups inside each other, and that's something I want to show you in the next video as well.